Hello, this is Mr. Anderson for Kellogg Community College. And in this video, we're going to be looking at the first two problems in the worksheets here that will cover the 6 different processes, or the half angle and double angle formulas for sine, cosine, and tangent. We're going to only do one page here. So we're going to do basically 12 problems based on this first part, which is kind of setting up our triangle that we need to find the sine, cosine, and tangent of the half and double angles from this given picture. Now what we're given is that the cosine of theta is 3/5, and we're within the first quadrant. So that's going to mean that we're going to create a right triangle for reference here in the first quadrant, so our x's and y's are both positive. And because cosine is the adjacent over hypotenuse, that using our Pythagorean theorem, we can then deduce that the other side of the triangle is 4. Because 3 squared plus y squared is going to be equal to 5 squared. Or, as you see here, 9 plus y squared is equal to 25. And if I move the 9 to the other side, y squared is equal to 16. Take the square root of both sides, and we'll take the positive value of 4 because we're in the first quadrant. So this gives me the triangle that we're going to use for all 6 of these problems. So we're going to keep referring back to this when we start asking for sine, cosine, and tangent of theta. We're going to use this triangle to get those 3 values. So the first of 6 parts here is we're going to take the sine of 2 theta, and the sine of 2 theta from the previous section, or the previous video here, we established that that's 2 sine theta cosine theta. So what I'm going to do is go to my right triangle and plug in the values, the exact values for sine of theta and cosine of theta. That sine of theta is going to be opposite over hypotenuse, so that is 2 times 4/5. And then the cosine is adjacent over hypotenuse, so that's 3/5. So 2 times 4/5 times 3/5 is, if I multiply top times top times top, bottom times bottom times bottom, 2 times 4 times 3 is 24, and 1 times 5 times 5 is 25. So my answer for part A is 24/25. Again, sorry that looks a little sloppy there. Part B, we're going to do the cosine of 2 theta. So the cosine of 2 theta, we have 3 different equations for this, or 3 different equivalent expressions for cosine of 2 theta. The one I like to use the most is cosine squared theta minus sine squared theta. And since we have our right triangle here, it's just really easy to kind of pick from this expression there. So this is going to be 3/5 squared minus 4/5 squared. And then we convert these. 3/5 squared, this is going to be 9/25 minus, and then 4/5 squared is going to be 16/25, which reduces down to 7/25. So that's our answer for part B. Now what we're going to do is work on the half angle formulas. And the half angle formulas that start in the first quadrant are pretty easy, because if you take any angle that's in the first quadrant and cut it in half, it still remains in the first quadrant. So when we choose our plus or minus based on the formula, you'll see we'll be choosing the positive. So the sine of 2 theta, or theta over 2 is going to be plus or minus the square root of 1 minus cosine theta divided by 2. Now, we're going to choose the positive of the 2 because we have to make a choice, and the reason why, and I'll repeat this again, is that we're in the first quadrant. So what we're going to do is take that angle, cut it in half, and any angle in the first quadrant cut in half will give us an angle in the first quadrant. So this means that we're going to have the square root of 1 minus 3/5 divided by 2. And using our calculator technology, or just the idea of getting a common denominator in the numerator, 5/5 minus 3/5 is 2/5. Now, this 2/5 is divided by 2, which is another way of saying by multiplying by 1/2. So again, all I've done to go from here to here is I subtracted 1 minus 3/5, which gives me 2/5. and then dividing by 2 is like multiplying by 1/2. So this gives me an answer of, in the numerator, we got 2 over 10, or 1/5. So I can turn this into the square root of 1 over the square root of 5, which I can then turn into 1 over square roots of 5. Now we cannot leave the square root of 5 in the denominator, so we rationalize it, and how we rationalize the denominator is multiplying top and bottom by the same number, or multiplying by 1. So the square root of 5 over square root of 5 will then make the numerator square root of 5, and the denominator is square root of 25, or just 5. This is your answer for the sine of alpha, or in this case, theta, divided by 2. Now D, we're going to do the cosine of theta divided by 2. And it's a similar function right here, except that instead of having a minus, we have a plus. So we're going to choose the positive, just like we did, because cutting an angle in half in the first quadrant gives us an angle in the first quadrant. So this is going to be 1 plus cosine of theta, instead of minus, divided by 2. So the problem's going to have some similar steps to it, except that in the numerator now we have 1 plus 3/5 instead of minus 3/5, divided by 2. And so 1 plus 3/5 is like saying 5/5 plus 3/5, so it makes a total of 8/5. Now 8/5 divided by 2 is the same as multiplying by 1/2. So this gives me 8/5 times 1/2, so another way of writing that would be 4/5. And I got that because I would have 8 over 10, and 8 over 10 simplifies to 4/5. I'm going to break up the square root using the quotient property and learned in Math 121. And so the square root of 4 over square root of 5 is 2 over square roots of 5. To rationalize the denominator, I will do the same trick as I did before. Multiply top and bottom by the square root of 5 over square root of 5. And this gives me an answer of 2 square roots of 5 over 5 is my cosine of theta divided by 2. Alright, so there is the fourth step of my 5-step process. Now you'll notice that the homework doesn't actually include tangent of 2 theta or tangent of theta divided by 2. So I actually want you to add into the problems yourself. So anytime you do a homework problem in this section, add these two to them to give you that help that you need. Now the tangent of 2 theta is the formula of, let's see here, 2 tangent theta over 1 minus tangent of theta squared, or tangent squared theta. Well, if I plug in my values, I'm going to have 2 times, now tangent is opposite over adjacent, so this is 2 times 4/3 over 1 minus 4/3 quantity squared. So my numerator of the problem will be 2 times 4/3 or 8/3. And my denominator of the problem is going to be 1 minus 16/9. Now I can't simplify that 8/3 anymore, so I'll just leave it as 8/3. But 1 minus 16/9, again using your calculator or just making this 9 over 9, gives you an answer of negative 7/9. But instead of dividing by negative 7/9, I'm going to multiply it by negative 9/7. Now what this allows me to do, it allows me to multiply straight across and do some simplification, because negative 9 is divisible by 3. And this eventually, if you do the problem correctly, it breaks down to negative 24 over 7. Now if you didn't do any simplification, this would be, let's see, 24, 48, 72. 72 over 21, but then you can divide top and bottom by 3, and you'll get your 24 over 7. So there's your answer for part E. And as you do these problems, does this seem like more of a problem that really tests your ability to do algebraic manipulation? I think that's the case, and I feel like it's a pretty good shot to really sharpen up your algebra skills from Algebra 2, Intermediate Algebra, or whatever the predecessor to this class was. Now, for the tangent of theta divided by 2, The formula that you may try to memorize is the plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. But the formula I prefer is 1 minus cosine theta over sine of theta. And the reason why I prefer this equation is because it's less junk in the denominator and it doesn't have that plus or minus thing that you have to keep concerned about when you do the half angle formulas. So what I'm going to do here is just kind of rock out the formula with you. 1 minus cosine theta is 1 minus 3/5 divided by sine of theta, which is 4/5. Now I'm going to process that numerator. 5/5 minus 3/5 is 2/5. And instead of dividing by 4/5, I'm going to multiply by 5/4. And 2/5 times 5/4, the 5s would simplify, the 2 and the 4 would simplify. You could get 10 over 20 if you didn't, but really the answer is 1/2. 2/5 times 5/4 is 1/2 according to the properties on your calculator, or if you just do top times top, bottom times bottom. Now this problem worked out okay, didn't it? But you know, we're really going to take up the difficulty a little bit by giving you a triangle in the next problem that doesn't have all whole numbers. And unfortunately the real world doesn't always give us that, you know, nice pretty whole numbers. So here we go with the next part of the problem. Because you'll notice that we're not in the first quadrant anymore. We're between pi and 3 pi over 2. And if you convert that into degrees, this is 180 degrees to 270 degrees. So what this means is that we are in the third quadrant, which means our third quadrant's triangle would be written like this. Here's your theta, right there. Your x's and y's would be negative and your hypotenuse would be positive. So the tangent of 1/2 is opposite over adjacent. Now we got to find our hypotenuse here. So using the Pythagorean theorem of -1 quantity squared plus -2 quantity squared equals the hypotenuse squared. You've got 1 plus 4 equals h squared. Sorry, that 4 again looks pretty bad. So 5 equals h squared. So if you take the square root of both sides, your hypotenuse is going to be the square root of 5. And this problem gains a lot of difficulty dealing with the idea that we have the square root of 5. I might be doing some things that might be different than your approach, but please understand that you and I can still come to the same answer using different techniques, but they will, you know, get there, you know, at the same time. The sine of 2 theta, that is the first part. We're going to do the double angle formulas for sine and cosine, then the half angle formulas for sine and cosine. Then we're going to do the double angle formula and the half angle formula for tangent. So this is the first of 6 parts before this video wraps up for this page. So the sine of 2 theta, this is going to be equal to 2 sine theta cosine theta. And according to our triangle here, sine theta is going to be -1 over square root of 5. So this is 2 times -1 over square root of 5. Now, before you start rationalizing the denominator here, because we can't have square roots in the denominator, just hold back a little bit and see what happens if I put cosine theta up here too. This is going to be -2 over square root of 5. Now, if you go through this problem from left to right, top times top times top, and then bottom times bottom times bottom, because this is 2 over 1, you'll get an answer on the top of 4. Now down below, you got 1 times square root of 5 times square root of 5, which is the square root of 25, which gives you 5. So this is your answer for part A. Now, for those of you who rationalize the denominator right away, you're going to find that that actually might add more work to your load. In fact, there will be problems coming up later on in this video here that will be better if you hold off of working on the denominator so quickly. Alright, so now cosine of 2 theta is equal to cosine of squared theta minus sine squared theta. Okay, so cosine squared theta is, let's see here, -2 over square root of 5. Now this is quantity squared, minus sine, which is -1 over square root of 5, quantity squared. And what's great about these is that when you square this, the -2 times itself becomes 4, and the square root of 5 squared is just 5, minus. -1 squared is just 1, and the square root of 5 squared is just 5. So what we have is a simple answer of 3/5. Oh, if everything in this problem was this easy, but now we're going to get into some trickier math here as we do the half angle formulas. Now, let's go and look at just the half angle formula first. The sine of theta divided by 2 is going to be equal to plus or minus the square root of 1 minus cosine theta divided by 2. Now, what's important about this is we have to think that if we take the half angle in the third quadrant, we have to know where that is on the triangle. If we take half of an angle in the third quadrant, we are not going to be in the third quadrant anymore. In fact, we're going to be in the second quadrant. So what I want to do is I want to kind of make a box or a rectangle underneath this right here to show you that for the half angle, so when theta is divided by 2, we're going to be between 90 degrees and 270 cut in half, which is 135 degrees. And that means that we're going to be in the second quadrant. And our sine in the second quadrant is positive. It's the y value. So a lot of students who forget about these half angle formulas, because we are going to be, you know, your angle divided by 2 is between 90 and 138 degrees. A lot of people who forget about these will just instantly put down negative because they think everything's negative in the third quadrant except for tangent. So unfortunately, this kind of kicks you around a little bit, that the third quadrant cut in half for the half angle formulas will be in the second quadrant, not the third. So I'm going to put a little Roman numeral 2 here because that's going to be important for part D. Well, now let's actually compute the problem here. We are going to have the positive square root of 1 minus, and let's look at the cosine. Cosine is going to be negative 2 over square root of 5, and that's all divided by 2. All right, now we got to work on this numerator here a little bit. So we have the square root of, I think in this case, there's a couple different tactics here. Some people decide to rationalize a denominator right now, and that would give me as 1 plus 2 square root of 5 over 5, all divided by 2. Now, the trick of that and how this happened is the two negatives made a positive, and I had 2 over square root of 5, so I multiply top and bottom by square root of 5 over square root of 5. I get 2 square roots of 5 over 5. Now I'm going to get a common denominator here in my numerator, so I'm going to turn this 1 into 5 over 5. The numerator now is 5 over 5 plus 2 square root of 5 over 5, so I got 5 plus 2 square root of 5 all over 5. Now this whole thing is divided by 2. So instead of dividing the whole thing by 2, I'm going to multiply by 1/2. So instead of writing it like this, I'm going to multiply by 1/2. So this next piece of the problem is going to be 5 plus 2 square root of 5 all over 10. And this is where I'm going to stop. And the reason why I'm going to stop is because I got a root in a root. And going further is not going to make the problem any easier. In fact, you know, we can get rid of this square root of 10 in the denominator, but we might as well just quit while we're ahead because this is an equivalent expression, which will take care of everything we need. So that's part C. Part D is going to see this trick happen here again. Here's cosine theta divided by 2 is equal to plus or minus the square root of 1 plus cosine theta divided by 2. Now, we will choose the negative of this one because we're in the second quadrant, and cosine, the x value in the second quadrant, is negative. So our answer is going to be negative, and we're going to plug our stuff in here, which is 1 plus, and then we'll have negative 2 divided by square root of 5, all divided by 2. We'll take things a little bit, we'll go a little bit more streamlined here because we have seen this before. It's like this over here, but negative instead of positive. So I'll rationalize the denominator and get a common denominator of 5. So this is going to be 5 minus 2 square root of 5 over 5. Again, taking me to this step down here. And I'm going to multiply by 1/2. Again, taking me down to this step here. And this gives me negative 5 minus 2 square root of 5 over 10. Alright, so if you struggle with some of these basic computations, please see me in class and I can go over some of the steps I'm skipping. So that was part D right there, and now we're going to rock to part E, which is going to be looking at the tangent of 2 theta. And what's nice about this is that, you know, since the tangent of 2 theta just taps the equation for 2, excuse me here, doodle-doodle-doo. I just got to make sure I wrote down I didn't, 2 tangent theta divided by 1 minus tangent squared theta. Now the tangent of theta is really nice because the tangent of theta is negative 1 over negative 2, opposite over adjacent, from theta up here. And then what we have is 1 minus, and here we have negative 1 over, oh, there should be negative 2 there, negative 2 quantity squared. So the 2 times negative 1 and negative 2 is the same thing as 2 times 1/2, which is 1. Down here, what we have is 2 minus negative 1 squared and negative 2 squared, or 1 minus 1/4. So what we have is 1 minus 1 over 1 minus 1/4, which is 3/4. So 1 divided by 3/4 is like taking the reciprocal of that, which is 4/3. Or you can, you know, skip, flip, multiply. 1 times 4/3 is 4/3. So part E is a nice break before the storm of part F. Part F is taking the tangent of theta divided by 2. And the problem I want to do, or the step I want to do, is I want to take my 1 minus cosine theta divided by sine of theta. Okay, so in my numerator I have 1 minus, and if I look at my cosine is going to be negative 2 over the square root of 5. All divided by sine. And the sine is going to be negative 1 over square root of 5. Now, I think what a lot of us try to do at this moment is to rationalize the denominators, but that is just going to actually add an extra step. Because I'd like you to look at this numerator, and I'd like to get a common denominator here, so I'm going to turn that 1 into the square root of 5 over square root of 5, plus 2 over square root of 5. And that's over negative 1 over square root of 5. So in my numerator now, if I combine these two terms up here, I get 2 plus square root of 5 over square root of 5 divided by negative 1 over square root of 5. So now I have a complex fraction, a fraction over a fraction. And when we have that, we're going to skip, flip, multiply. We skip the first fraction completely and write it down. And then we take the second fraction and we flip it on its head and multiply instead of divide. Now in doing so, we can cross-simplify these two problems, and many people call that cross-canceling, so those 5's go away. So we have 2 plus square root of 5 divided by negative 1. Now since this is a monomial in the denominator, I can take everything in the numerator and divide it by negative 1, like so. And that gives me the answer that matches the back of the book, negative 2 minus the square root of 5. So there's your answer to parts F, E, D, C, B, and A. So you're probably thankful that I only gave you 6 of these problems in the homework, but since these 6 problems has 6 parts, you're doing 36 pretty complex manipulations to get the problem done. Well, thank you for watching the video, and I hope this helps, and I will talk to you soon in class, and please email me if you have any questions.